Hello everyone, my name is Teja. I am presenting the artificial neural network in machine learning project work. Let's see the what is artificial neural network is. Artificial neural network is a type of machine learning model. It is mainly inspired by structure and function of human brain. It is designed to recognize the patterns, make decisions, and solve the complex problem in a area such as image recognition and natural language processes. And let's see the introduction to ANNS. ANNS, Artificial Neural Network, are a computing system inspired by the way human brain processes information modeled after the structure and functioning of biological neural networks. ANNs are designed to recognize patterns and solve the complex problems in a way humans do. At the core, ANNs are interconnected units called neurons, which act as a processors. These neurons are organized into layers, and information flows through them in a structured manner. This layered architecture allows ANNs to learn from data, adapt, and improve the performance over a time. ANNs are a fundamental components of machine learning and artificial intelligence. They are widely used in various advanced applications, including the image recognition, speech recognition, and natural language processors. Let's see the architecture of artificial neural network. The architecture of artificial neural network refers to how its neurons, also known as nodes, are organized and connected. A typical ANN is structured in layers. Each layers play a specific role in data processing. There are mainly three types of layers. First, we have the input layer. This is where the data enters the network and it receives the raw data from the external world. Then comes to the hidden layers. These layers process the input data and through the weighted connection. The networks learns the patterns and future in this stage by adjusting these weights. Finally, the output layer produces the final result or prediction based on what processing done in these hidden layers. The data flow from input layer through one or more hidden layer and finally to the output layer. This forward flow of data is what enables the ANN to perform complex tasks like a classification, prediction, and pattern recognition. In summary, layered structure of artificial neural network is what makes it such a powerful tool in artificial intelligence. Let's see the different types of artificial neural network. Feed forward neural network, cascade neural network, recurrent neural network, convolutional neural network, recursive neural network, FitNet shallow neural network. Let's see the each one by one closely. Now let's explore the different types of neural networks, each designed for specific tasks in machine learning and artificial intelligence. First, we have feed-forward neural network. This is the simplest and most basic type of neural network. Here, data flow only in one direction, from the input layer to output layer, with no loops and cycles. It is widely used in classifications and regression tasks such as predicting whether an email is spam or not. Advantages including fast computation and easy of training, especially on small datasets. These networks are ideally when the input is independent and does not rely on any sequential information. Second one, we have cascade neural network. This is a more dynamic from a neural network. Here, neurons are added progressively during the training, and each layer is connected to all previous layers. It allows the network to automatically grow in complexity based on the data, reducing the need to predefine the architecture. It helps when you want to the network to adaptively learning complex relationship in data without overlifting. It typically result in faster converging and better generation. Now we have third one, concurrent neural network (RNN). RNNs are specialized for the sequential or time-dependent data. They contains feedback connections, meaning they can maintain a memory of previous inputs. Perfect for tasks such as speech recognition, language modeling, and time series forecasting. However, they may struggle with long sequence due to the vanishing gradient problems. RNNs are crucial for systems that need to understand context over time, like chatbots or translation system. Fourth one, convolutional neural network. CNNs are powerful for handling visual data. They are used to conventional layer to automatically learn spatial hierarchical of features such as degrees, shapes, and textures. CNNs are widely used in image clarification, object detection, and video analysis. They reduce the number of parameters significantly using weight sharing and pooling layers. CNNs are also being extended into audios and textures domain due to their future extraction capability. Fifth one, recursive neural network. These are different from the recurrent networks and operate an hierarchical structured data such as trees, commonly used in natural language processing to understand the grammatical or semantic structure. They recursively apply the same set of weights along the structured input, like parsing nested expressions or analyzing the sentence trees. Useful in sentimenting analysis, sentence comparison, and sentimenting parsing. Recursive networks capture structural relationship rather than just sequential one. The conclusion part. The conclusion part clearly tells that artificial neural networks are the fundamental pillars of modern deep learning. Their flexibility and power making suitable for wide ranging of tasks from simple classification to complex decision making processes. Today, neural networks are the art of advancing in many industries. In healthcare, they assist in the disease detection and personalized treatments. In finance, they help detecting the frauds and predicting the market trends. In marketing, they enables the customer segmentation and targeting advertising. In transportation, benefit through the neural network that self-driving technology and route optimization. In gaming, they create intelligence, adaptive behavior in virtual environment. Thank you.
Thank you, Teja. My name is Ajay. I am going to explain what the codes. First one, install required packages. Pip install Scikit learn pandas matplotlib seaborn. In this course, we start by installing all the necessary Python packages. This includes libraries for data manipulation, visualization, and machine learning models. Second one, import libraries. Import the zip files. Import pandas as PD. Import numpy as np. Import the all the files into the codes. Next, we import all the required libraries. This helps us handle files, pre pre-process data, visualize it, and build machine learning models. In this, all the logical recursion and multiple normal NPs, these are courses included in the import libraries. Third one, load dataset for zip. In this code, we have to implement contact active ninth zip. We have to implement the copy path into the code. It will give the output. Or we're loading the dataset from a zip files without exiting it manually. It reads the SVS file directly from the compressor active. Fourth one, pre-processing. In this code, we have to implement the object and columns, text column, label column. We we remove any rows with missing data to keep our dataset clean. Then we identify the text the label columns labels we encoded into numbers giving label encoder. Next one, fifth one, TF IDF vectorization. Vectorizer, if so, in this code we have to implement the vectorizer x and y vectorizer, flit transform, and text column and array. We convert our text data into numeric format using TF-IDF, which capture how important a code word in the document. Retrieve the We limit features to the top 1,000 most significant words. Sixth one, train text split. This code implement the train text, train and text, and implement the sizes and state. We split in the dataset into training and testing sets. 80% is using for training, 20% is used for the executing model performance. Seventh one, visualize label distribution. In this code, you have to implement the label distribution. We will add the code in the we have to execute. This plot helps us understand how balanced our classes are. If the distribution is slacked, it may affect model performance. Eighth one, train multiple models. In this code, we have to implement the six different codes: logistic regression, Navi Bayes, SVM, decision trace, random forest, KNN. Or we define a dictionary of multiple models: logistic regression, Navi Bayes, SVM, decision trace, random forest, and nearest neighbors. This lets to quickly compare their performance. Ninth one, evaluate models. For name models is in models items. Models is flit X train and Y train. Preads and models predict X test. We have to implement the predict and X test in the ninth executes models. We train each models and print its accuracy. This gives us the idea of which model performance based on the our dataset. 10th one, confection matrix of the best model logistic regression max letter 1000. We choose logistic regression as the best model and evaluate it using a confection matrix. This gives a more related view of the classification performance, like how many true positives versus false negatives we get. These are the code explained. These are the codes is executed in the below graphs. These are the graph executed in the label distribution, count, prediction, 0, 1, 2. These are the up, low. These are the graphs. Logistic regression accuracy is 0.45. Naive bias accuracy is 0.45. SVM accuracy is 0.45. Decision trees is accuracy is 0.45. Random forest accuracy is 0.45. KVN accuracy is 0.45. 42. Sorry. Confection matrix logistic regression. Actual predicted. These are the graph of the codes. Next code is install required libraries. Pip install minus q pandas numpy metaplot lib cbron scikit learn. In this code, we begin by installing initial libraries used for the data handling, visualization, and machine learning modeling. Second one, import libraries. Import pandas as PD, numpy as np, cborn as sns, matplotlib is a plot. This These imports for grouped logically data manipulation, visualization, model building, and visualization matrix. These are the codes are used in the given codes. Third one, extract the data set. In this code, we have to implement the copy path and it give the output. Instead of manually unzipping the file, we automate extraction using Python, making the process reproducible and cleaner. Fourth one, load dataset. In this code, we have to implement the SVS files, extract path and end with SVS. It dynamically detective the SVS files inside the extend folder and load it into the data frame using pandas. Fifth one, dataset info. Print df shape df info. In this code, this gives a snapshot of dataset size and such a number of rows, columns, and types of data. It gives the number of columns, rows, and columns and types of data. Sixth one, check and drop nulls. Print nulls values. Diff is null, sum and null. It gives the in the data. Sixth one, we check for missing values and drop any incomplete records to resolve our models train on clean data. Seventh one, identify text and label columns. Text column and label column implemented in the implemented in the codes include object and columns. We automatically detect the text and label columns based on the data types and columns position. Eighth one, encode labels. In this label, we have to implement the fleet transformation. We convert category labels into numeric form so machine learning models can interpret them. Ninth code, visualize class distribution. In this code, we have to implement the class distribution. It gives the output. This chart shows the distribution of classes. Imbalanced classes can influence models performance and bias. Tenth one, TF and IDF vectorization. In this code, we have to implement the English word and max futures and thousand. X and Y, you have to implement the text column and as type str string to array. TF-IDF transformation and the text into the numeric format will reducing noise from common but unfructable words. 11th one, train text spread. In this code, we have to implement the train text and size and text state. We have to implement these are codes. We have to give the output. We split the data set to evaluate model performance on unseen data using an 80 to 20 ratio. 12th one, logistic regression. In this code, in these codes are six different classifiers. First one, logistic regression, Mavi bias, SVM, decision trees, random forest, KNN. These are the six classifiers. First one, logistic regression. In this code, we have to implement the extrain and ytrain. It gave the output the 13 on Dave Bryce, Navi Bryce. NB multi multi-normal extrain and ytrain you have to implement. It gave the output 14 SVM liner SV, SVC. You have to implement the extrain and ytrain. It gave the output 15 decision tree. Decision tree classifiers extrain and ytrain. You have to give the output random forest. Random forest classifiers is you have to implement the extrain and ytrain. It gave the output KNN. K neighbors classifiers extrain and ytrain. It gave the output. 18th. Compare model accuracy models. Model in this regards you have to implement six classifiers: logistic regression and Navi bias, SVM, decision tree, and random forest KNN. We evaluate all the models on the test set using accuracy as the matrix and store result in the dictionary for compression. 19th one. Plot model accuracies. This vision comparison clearly shows which model performed best and they how much it helps us make a informed choice. Eighth one, confection matrix for best model. In this code, you have to implement the predictive active and X label and Y label. You have to give the output. Do we identify the top performing model and analyze its prediction further as using a clarification report and confection matrix? These tools reveal the model's prevision, recall, and how will it distinguishing between classes. These are the codes are exhibited in the below. In these codes, this is the output: class distribution prediction and 0, 1, 2, 3. 10,000, 20,000, 30,000, 40,000, 50,000, 60,000 count. First graph is low and below I and below. It is a graph. In this graph, six classifiers ratios are given in the output: logistic regression 0.45, Navi bias 0.45, SVM 0.45, decision tree 0.45, random forest 0.45, KNN 0.42. Model accuracy compression. Accuracy, these are the graph of six clarif- cla- classifications. In this first one, logistic regression, Navi bias, SVM, discussion trees, random forest, KNN. These are the accuracy: 0.1, 0.0, 0.2, 0.4, 0.6, 0.8, 1.1, 1.0. Sorry. Model accuracy compression. These are the cores or graph of the outputs. Thank you.